All right, let's talk about defending our digital world. Today, we are diving deep into API security, breaking down 5 of the most common and most critical flaws that can leave the door wide open for attackers. Let's get into it.
Do you ever stop and think about it? When you're ordering a pizza, checking the weather, or using your Google account to log into another service, there's this invisible conversation happening, right? A constant back and forth of data. So how does that actually work?
Well, the secret sauce is APIs, application programming interfaces. The best way to think about them is as these invisible gatekeepers. They stand at the door, manage all the requests, and decide who gets access to what data. They are, quite literally, the backbone of the entire modern web.
But here's the thing. When these gatekeepers have vulnerabilities, when they have blind spots, that's when things get really bad. And today, we're going to shine a light on 5 of those critical blind spots.
So our first blind spot is all about authorization. And let's be clear, this isn't about who you are, it's about what you're allowed to do. The gatekeeper might check your ID at the front door of the building, but then totally fails to check if you actually have the key to the specific apartment you're trying to get into.
The most common version of this flaw is called Broken Object Level Authorization, or BOLA. Imagine you have a digital key that lets you see your own order history. Well, with a BOLA vulnerability, an attacker can just tweak the order number and the web address, and suddenly your key doesn't just open your history, it opens everyone else's too.
And what's so wild is how simple this mistake is. Look at this. The flawed code on the left basically asks, is this person logged in? That's it. The secure code on the right asks, okay, is this person logged in, and does this specific order actually belong to them? That one single extra check is the difference between being secure and having a catastrophic data breach.
So how do we fix it? Well, the key is to build that ownership check into every single request. No exceptions. You enforce it everywhere, you centralize that logic so it's not forgotten somewhere, and then you have to actually test for it. Seriously, log in as user A and try your hardest to grab user B's data. That's how you find these holes before the bad guys do.
Now, BOLA has a nasty cousin, Broken Object Property Level Authorization, or BOPLA. In this case, the gatekeeper might stop you from seeing a sensitive piece of information, but completely forgets to stop you from changing it. So an attacker might not be able to see if a user is an admin, but they could just send a request saying, hey, make me an admin, and the system just does.
You can see exactly how this works right here. The flawed system on the left just blindly trusts whatever data the user sends it, including a little something extra like admin true. The secure fix on the right is to have a strict list, a whitelist, of only the things you're allowed to change, like your name or your profile picture. Anything else that comes in, just ignore it.
The big takeaway here is you need a zero-trust mindset. For any data coming in, you whitelist the exact fields you'll accept. Never, ever just trust the request body. And for data going out, you use sanitized objects so you're never accidentally leaking sensitive info from your database. It's all about tight control, property by property.
All right, on to our second blind spot, authentication. This is all about identity. If authorization was about what you can do, authentication is about proving who you are in the first place.
You know, when authentication is broken, your gatekeeper is just easily fooled. It's like a bouncer at a club who sees a horrible hand-drawn fake ID and just says, yep, looks good, come on in. They're letting imposters walk right through the front door. This here is a classic technical error. Think of a digital token, like a JWT, as an ID card. The flawed code on the left just decodes it. That's like just reading the name on the card. The secure code verifies it. That's like checking the hologram, making sure the signature matches, and checking the expiration date to be sure it's not a fake. It's a world of difference.
So, the rules for this are simple, but they are strict. First, you always verify tokens. You never just decode them. That is absolutely non-negotiable. Second, you whitelist strong, modern encryption algorithms. Third, you've got to protect your login pages with rate limiting to shut down brute force attacks. And finally, please don't try to be a hero. Use proven, battle-tested identity solutions instead of trying to build your own from the ground up.
Okay, our third blind spot is kind of a 2-for-1 deal. It's all about consumption. This covers 2 big problems. First, what happens when your gatekeeper gets totally overwhelmed by too many requests? And second, what happens when it blindly trusts information it gets from others? So, first up, resource consumption. Picture an API that lets you pull up user comments. If you don't put any limits on it, an attacker can just ask for all the comments, millions of them, all at once, over and over. This completely overwhelms the server, and it either grinds to a halt or just crashes for everybody. That's a classic denial of service attack.
And this chart really puts the scale of the problem into perspective. I mean, look at this. A normal, everyday request might be tiny, a few kilobytes. But an attack request can be thousands, even millions of times larger, just gobbling up all the memory and CPU and bringing the whole system to its knees.
The fix? You have to set boundaries. You build walls. First, use pagination. Only return, say, 50 results at a time, not the whole library. Then, you apply rate limiting to stop one user from hammering you with thousands of requests a minute. And finally, you set strict timeouts and size limits so one bad request can't lock up your resources indefinitely.
Now, the other side of this coin is about trust. Most apps today rely on third-party APIs for things like weather data or payment processing, and the huge mistake is to just assume that because the data is coming from a partner, it must be safe.
Here's the scary part. On the left, the flawed code just takes whatever the partner API sends and passes it right along to the user's web browser. So if that partner gets hacked and starts sending malicious code, guess what? Your application just became the delivery system for an attack. The fix is to treat all external data as hostile and validate it against a strict schema before you even think about using it.
This really requires a paranoid mindset, in a good way. You have to validate and sanitize everything that comes from the outside world. Treat your partners like any other untrusted user. It also means you should lock down your outbound calls to only the services you absolutely need, and use patterns like timeouts, so if a partner's system goes down, it doesn't take yours with it.
Whew, okay. We've covered a lot of ground. Authorization, authentication, consumption. So how can we boil all this down into something you can actually use? Well, let's build a simple, powerful checklist for our gatekeeper to fix these blind spots.
It really just comes down to this. If you can confidently answer yes to these 5 questions for every single one of your API endpoints, you have defended against the most common and damaging attacks out there. This turns a bunch of complex security theory into a straightforward, practical guide.
And really, that's the final thought to leave you with. The digital gateways we all depend on every single day are only as strong as the questions they're programmed to ask. The safety of all our data depends on developers getting these fundamental questions right every single time. Thanks for digging into this with me.